Hello and welcome to my channel. If you haven't subscribed to this channel, hit up the subscribe button below. So in today's video, I'm just going to be taking you through a walk down of the just concluded IndabaX competition. So let's just run through it. So the competition was all about water potability classification. That's just to determine which water is suitable to drink or not. So let's just quickly go a little bit and see what the data set contains. So like for every competition, as we know, we have like the train, the test, then the sample submission. So we just quickly look at it. So for the train data set, we have about 2,260 rows, and the test we have 1,016 rows. So let's just quickly take a little bit info about the competition. So I'll just run through this. The government of Nigeria is concerned with the exponentially increasing mortality rate due to the ingestion of unsafe water. So what is our work here? You have been contracted by Water Corporation in Nigeria to use artificial intelligence in automating the classification of water potability. This will serve as a decision support system for the experts in this field. So the whole process that have been done with in taking account of in like checking which water is suitable or not was manually. So now you are being employed to determine with AI which water is good for drinking. So we have different attributes in these data sets that we are going to be looking at to determine which water is suitable for drinking or not. Let's just check the data again. I think it's displayed here. So the pH value. pH is an important parameter. pH in evaluating the acid-base balance of water. It is also the indicator of acidic or alkaline condition of water status. So we have the pH value, we have hardness. Hardness is usually caused by calcium and magnesium salts in water. Then we have solid, total dissolved solid, TDS. We have chloramines, we have sulfate, we have conductivity, we have organic carbon, we have trialomethanes, we have turbidity. Then this is the goal. This is like what we are trying to predict. We are trying to predict whether the water is potable or not. Portability in the case if water is safe for human consumption, where 1 means potable and 0 means not potable. So these are the data provided by the IndabaX community, and here we are just trying to determine which water is potable or not potable. So let's just dive into it immediately. Yeah, so this was the solution I submitted to IndabaX. This solution, let's go back to the competition and see. No, that's a mistake. All right, so we'll quickly check the leaderboard and see the people that topped the leaderboard. So this is the leaderboard of the competition. My solution placed me 5th place. Actually, this was without the leak. The competition had the leak. The leak was in the region ID. So like there is a rule in ZD platform that you must not use the ID as part of your solution. So I can't really say if these guys use the ID in their solutions, but like the F1 score, like because the metric we are using here is the F1 score. Like this F1 score is just too good to be true. Like everything here is close to 1, and like the closer to 1 the better. So imagine an F1 score of 0.99, like that's like a very, very good solution. So my solution placed me 5th, and I'm just going to be showing you what I did in my solution, and I'm just going to be using the leak again, and we are going to see where the leak will place us on the leaderboard. So let's just dive into it straight. Yeah, so like the first thing we do in every competition, like not in competition. If you're working in a real world scenario, also you have to like import the libraries you are going to be using. So yeah, these are all the libraries I'm going to be using. I'll just quickly skip that. So after that, then I check for the data set. So yeah, we are provided with our train. So the train is the one you are going to be training your model on, and the test is the one you are going to be submitting to Zindi to have a position on the leaderboard. So we have the train here, then we have the test, then the sample submission. So the sample submission are always given to like check to show you how you're going to submit on the leaderboard. So the sample submission is always with an ID. With an ID, then like the solution your model is predicting. For our own case, it is the portability. So you have the ID and if the water is potable or not. So what I'm just doing here is just checking the shape of the train. The shape is just like the size. So this is the row and this is the column. So here we have 2,260 rows and we have 11 column. Here we have 1,016 rows and 10 column. So let's just check it again. Let me see if this will run very fast. It's quite slow. If you see a star here, that means it's still running. Once it shows a number, it's done running. Okay, it's done running. Yeah, let's move it. So let's just check the head of the train. So train.head. So checking the head of the train, you are going to be seeing the features you are given to train on. So here we have region area. So like according to Zindi rule, you are not meant to use the region area as part of your solution because region area is the ID, like the identification of a particular, like, yeah, identification of a particular like sample. Yeah, so like for this sample, this region area 1, this is like the identification of this. So we are not meant to use it as part of our training. So we have the pH, then we have the hardness, we have solids, chloramine, sulfate, conductivity, organic, carbon, trihalomethane, turbidity, and potability. So like one thing I do before I like start any new competition is I just try to research about the data set. Like I just try to look up things online. Like I went online and check about pH. I'm actually a science student, so I have like a bit of knowledge. I know what pH is and some other thing, but like still I still had to just go online and still look up some stuff, just check like the relationship between pH and hardness, how like maybe if solids increase, the chloramine decrease, how the conductivity affect the organic carbon, or like just relationship between the variables given and how they affect the main goal, which is the portability. Yeah, so we'll just move on. So like the thing I love to do with competition is I just like to join the whole data set together because that helps me speed up the code writing, because like I can't, if anything I do for the train I have to do for the test, so I don't want to like build a feature for test, I'll now have to write it for train again. So I just like join everything together. So anything I do automatically for train, I do it for test. So this is the way I do it. Like I just do pd.concat just join this train and test together, and this is to be able to like separate them at the end later. So if you notice here, what I'm just doing here is just trying to check like the number of unique region area, because region area is the ID, like I said earlier. So we have 303,276 rows when I join the train and test together. And when I check the unique region area, it is also 3,276. So it will not actually be good to use it as part of our training data. Yeah, sorry, come here, I need to check something a bit. Okay, still recording. Yeah, I just need to confirm that. Yeah, I'm still recording. Oh, okay. Old pause. No. Yeah. So we'll just continue. So this is how we check like the unique value. Then what I was trying to do here is just checking the minimum of the pH value, maximum, and the rest. So like I built a lot of features actually for this competition, and I noticed like those features were not increasing my F1 score, because like the what we need to, okay, let's just go back to the info of the data set. Let's see, where's evaluation? Yeah, evaluation. Yeah, so the error metric for this competition is the F1 score, which ranges from 0. 0 is total failure. That means your model is not learning anything. Then 1 is perfect score. As the closer your score is to 1, the better your model. So the way I do my stuff is like, I build a feature, check the performance, check like the cross validation on my system. If it's not performing well, I zero it out, like, okay, this feature is not good. So that's how I test on different features and see the performance, then go like that. So let's just go back to the echo. Yeah. Then for pH, like pH has a range. So I looked this up online actually. So like there are different ranges for pH. So yeah, I just try to bin them. So if the pH is between 8.5 and 7, I just give it an 100. Else, if the pH is between this, I give it an 80, or else if it is between this, give it a 60. If it's this, give L 0. So this is what I just looked up online, and I said, okay, there's a range between this pH value, and this range should actually increase the portability, like it should correlate with the portability. So I named it as NPH. So like this is the first feature I built for this particular competition. So let's just move. Yeah, then for conductivity also, conductivity has a range, but this feature, like, it adds 0 value to the F1 score. Like it even reduced the F1 score. So I had to like just comment it out here. So I did not use it as part of the model. Yeah, then what I did, I had to drop the region area. So since it is not, I can't use it as part of my feature and building, but like I'm going to show you the score of using the region area and without using the region area. So since I can't use it, like I had to drop it here. Then another thing is for the missing value. So the pH, sulfate, and this trialomethanes, they have missing value. So missing value are like empty space, like there is no account for that particular variable at that particular, should I say time? I don't know. Yeah, so that is for missing value. So this pH has a missing value. Okay, let's check it out. Let's check it out. Yeah. So I've run this, Yeah, I've checked this. Let's come back here. So the way we check for missing value, so we'll do something like df dot is now, then we say dot sum. So like our pH, this is our pH. Our pH has a missing value. Then sulfate also have a missing value. Then trialomethanes also have a missing value. So we need to account for this missing value. We need to fill them up. So since they are blank, so how do we fill them up? Like there are actually different methods to fill missing value. There's not one straight way. So the most common one is just to fill it with the main, or fill it like with the mode. Like that's like the most occurring one. But like there are still actually like a very good way to fill missing value without using main and mode. Maybe you check the particular variable in relation with another variable. Maybe you say, okay, the higher, okay, let's check it out. Maybe we say like the higher the hardness, the lower the pH value. So we can just like maybe write a conditional statement regarding that. If the hardness is between, let's say, 180 to 300, the pH value is meant to be around, let's say, 3 to 4, that kind of thing. So they're actually very good way of doing that. Yeah. So let's just move. Where am I? Yeah. So the way I fill in the missing value is just with the mean. So for the pH value, I calculated the mean, then fill the missing space with the mean, sulfate, and also this. So like after filling the mean, then I check is null dot sum, and I see that okay, we have no value except portability. But don't forget, I joined the train and test, so like this is meant to be there. So we have 1016 rows missing for portability, which is the test, because that's what we are going to be predicting for. Yeah. So this is another thing I tried again. So k-means, so what I did is just try to cluster around a particular group of guys. So what I did was I tried for pH, sulfate, and chloramine. So I just like created cluster equal to 5. So we have like 5 different points mapped around like each of those points. So like the feature did not help the model. The aim is to increase, to have like a very good F1 score, but like by the end of trying this particular feature, my F1 score did not increase. So what do I have to do? Like I just had to like comment it out. It was useless. Yeah, then this was another formula I found online. So this formula was on I think the relationship between sulfates and pH. The formula, I don't understand the formula myself. So the formula is minus 1.1 times it's just like the relationship between them. It did not increase the F1 score, so I had to drop it. Yeah, then this is another one. So this is just like feature interaction. So feature interaction is just joining two features together, adding two together, just doing all those kind of sort of things. So what I did here was the hardness, I divided it by the pH to like create a new feature, and this actually improved the score. Interesting. Then I had to leave it here. I did not comment it out. Yeah, then this, okay, this is, I explained this already. This is just the k-means I tried doing up here. Okay, then I came back again. I tried pH, sulfate, and chloramine up. So yeah, I just tried only pH and chloramine. And now, this time, we just 2 clusters. And they improved the score, so I had to leave it this time. So like, competition is actually just trying features out, just trying things out, trying to see what can like improve your score, because that is the goal. That is the goal. We want to win. Yeah. All right. So then another thing I tried was the hardness binning. So what this will do is just try to bin the hardness and just put it in like categorical order. Then this actually increased the score. So if you see the binning here, we have 3, 4, 5, 6, 2, 7, and 1. Yeah, then I replace like all those infinity number with 0. Then after that, I tried some feature again, which did not improve. I tried dividing the pH labeled by the hardness. This did not improve. Then after all the feature engineering, you remember we join our train and test together. I have to split them. How do I split them? If we go up, I've already taken the shape of my train as n train and the shape of my test as n test. That's the number of rows in train. So I'll just use it to separate. So this is what I'm doing here now. Yeah, this is what I'm doing here now. So I've separated them, separated the train, separated the test. Now it's time for the main deal. That's building of the model. So like we need an X. Sorry, dehydrated. I need to take some water. Yeah, refreshed. All right, so now we need to separate them. We need to separate the S. The S is like the training, what you want to use to train. Then Y is like the actual value you want to predict. So here we are predicting portability. So in the X, we are going to have to drop the portability. Then in the Y, it will leave the portability. Then the ID is the region ID. So for the test also, we have to remove the portability. If you can remember, like because we joined, like the test does not have a portability, but now because we joined, it has a portability, so we have to drop it. So if you look at the count of our Y, because we have 0 and 1, 1 is the water is good for drinking, then 0 is the water is not good. The data set is actually very imbalanced. Like look at the ratio, is quite imbalanced. So one thing I tried was smooth. So smooth is used for like oversampling or just trying to balance a set of samples that are not balanced. So most time for me, smooth doesn't work. I don't know why it worked for this particular competition. I just, okay, let me try it. But to my surprise, it worked. So like, let's see what I did here. So for one, if you look at one had 878 samples in this particular competition. So using smooth, I had to like increase my 1 to 1000. Then for 0 that had 1382, I just increased it a bit to 1,400. So this was the sample I used, and this was what results in the best, the best solution. No, don't say the best solution. This was what placed me like my best score on the leaderboard. Yeah. Then the model, I used a light gradient boost classifier, just set some random, they were not actually random because I actually did a lot of testing to which work and which did not work. Then the one thing that actually made a big difference was this guy. This is balance equal to true, and this scale position weight. This scale position weight is actually very tricky because like the value is meant to be like the how do I put it? The value is meant to be the proportion of how the data set is imbalanced, but this was not actually the proportion, but this gave the best score. Then my learning rate was a bit small, 0.05. This actually helped in increasing the model performance as well. Then after that, we just fit, we fit the data set. Yeah, okay, one more thing, sorry. Then I tried voting classifier. So since like this was giving me like a very good score, this was giving me a very good score. So like I had to like just check other models that are not doing well. Not really not doing well. They are trying also, and just like to do like a voting classifier. So what a voting classifier would do is, if you have three model, and model A is saying 0, model B is saying 0, and model C is saying 1. Majority carries the vote, so it just picks 0. So that's what the voting classifier is doing. So yeah, I had the LGB classifier that was doing well. I had the cat boost classifier that was trying, and I built another LGB classifier with a different parameter. So after that, like I just used like an add voting method, like to just pick the ones that are predicting the same thing. Then after that, we fit our model. Then we just check the results on the leaderboard. So this was the one that gave me the best score. So now we are going to be trying it with the region ID. So yeah, I'm just going to come back here. So instead of dropping this region ID, I'll make it a feature. I'll add it as a feature, then run all and see the score it's going to give us on the leaderboard. So let's check first. Let's see the score on the leaderboard first. On the leaderboard, I have a score of 0.63. So now let's use the region ID and see what score is going to give us. That's a leak. So let's just try it. Let's try it. Okay. So run all above first. Okay, so let me check my DF now. Okay, so I'm just going to say I'm just going to label and code it. So fit transform. So say df dot region underscore area. Okay, so I'll just name this okay, let me give it a funny name, leak. Oh, that's not funny actually. Okay, all right, so I'm going to I'll just drop the region ID since I already have it as leak. So let's just go and run all and see the score. Okay, so now we are fitting. Yes, don't fit in. So I'm not going to use voting classifier here. I'll just predict straight. So we just want to predict straight. So I will just come here, remove vote add, put model dot predict. Then then I'll call it leak. Let's call it leak dot CSV. Okay, so I'll come back here. Now come here, get a score, upload, leak. Where is it? Downloads. Let me just search leak. Downloads. Water portability. Leak. Yeah. Leak.csv, get a score. Okay, yeah. Can you see the score? 0.92 92035. I'm sure if I did not use Smooth, I should have a better score, but I'm not trying that. Yeah. So like with the leak, you have a very good score on the leaderboard, but it's not acceptable. But yeah, so this comes to the end of this. If you have any question, just hit me up. Maybe you can just hit me up on LinkedIn, Twitter, anywhere, but don't forget to subscribe on this channel. I actually need to start posting videos on this channel. So like expect like more videos. So just kindly subscribe to this channel. Yeah, and I'll be uploading this code on GitHub. So in case you need it as a reference. Yeah, thank you for your time. Very much appreciated. Peace.